We're going to start on time just because I have a talk right after this, so I have to make sure I don't go over because I've got to run to another floor.
You can use a clicker if you want.
Okay. So this is us. I'm Steve Wong. I live in Los Angeles. I have been active in Kubernetes since 2015. At the beginning, I worked mostly on storage, but right now, I'm a co-chair with Fabio on the VMware SIG, which is charged with maintaining the cloud provider for running Kubernetes on top of the vSphere hypervisor. I'm also lead of the Kubernetes IoT and Edge working group.
And my name is Fabio Rapposelli. I work for VMware as well. I'm an engineer working Kubernetes upstream. So my day job is basically to make sure that Kubernetes is a healthy project. And I am, we're able to contribute new features and so on. So I'm mostly active in SIG Cloud Provider, obviously SIG VMware. I'm a co-chair with Steve, and SIG Cluster Lifecycle.
And don't forget, you took offense at me saying Italy and not your city. So tell everyone what city you're from.
So I live in Italy, but I live in a very small town on the East Coast. Very small, so it's far from everything. It's called Cervia. So I just give Steve a hard time because he says Los Angeles instead of United States, but
Well, if I said Cervia wasn't, they wouldn't know where that was.
Yeah, exactly.
So today we're going to talk about why the Kubernetes cloud provider, not just the VMware one, but all of them, are moving out of Tree and what that means. Then we're going to go into a deep dive of installing and configuring the new out-of-Tree cloud provider along with CSI storage. And Fabio is going to give a demo of that and address the migration options available for people who are already using the in-Tree version. So the original architecture of Kubernetes started with what are called the cloud providers built right into Kubernetes itself. This stuff was like built into the fabric as a tight mesh. And I think that, in the early days, maybe they didn't see the success of Kubernetes and the ultimate number of platforms that people would go to. What a cloud provider does, if you don't know this already, is that it's the abstraction layer that makes Kubernetes portable so that you can take Kubernetes and have the identical experience whether you're running on an Amazon public cloud, a Google public cloud, Azure, or on your own on-prem hardware with or without a hypervisor. And this cloud provider sits there and it contains the code that makes everything uniform so that when you write or deploy apps, the apps aren't even able to tell where they're running unless you do something stupid and intentionally try to pierce these layers. But the premise is that in order to be cloud native, the app should run identically regardless of where they're hosted. And the cloud provider layer is what does this mapping to whatever the underlying infrastructure actually is. So these 8 cloud providers are the ones that are built into Kubernetes automatically, whether you like it or not, as of version 114. Now, it turns out that having these cloud providers built into Kubernetes, it's easy if you're on one of those 8, but there are some problems. These cloud providers, if code in the cloud provider has a bug or needs a security patch, they can't actually be published independent of a full Kubernetes release. And for any given user, you're only going to be using one of these cloud providers at a time, yet the binary distribution of Kubernetes includes them all, so it's bloated unnecessarily. The code in these cloud providers runs as a privileged component of Kubernetes, so this can present security and stability risks because if something goes wrong in there, it can it can bleed over into the key components of Kubernetes itself. And finally, the steering committee and the architects have come to the conclusion that really Kubernetes should just be the standardized orchestration kernel or code, and these drivers or cloud providers should be completely independently maintainable by people familiar with that platform even free to declare independent release cycles, so that if we on the vSphere cloud provider wanted to get a release out 2 weeks after Kubernetes itself, we'd have the freedom to do that if the code isn't tightly coupled. So this move of the cloud providers out of the tree isn't really urgent, meaning it's the standard Kubernetes deprecation policy applies, meaning users get at a minimum of a 1-year notice that this is happening and aren't forced to march overnight to the new one. So there will be a period when both are available, and that we're in that period right now where the in-tree cloud provider for vSphere is still alive and well and present and supported, but the out-of-tree version is also there. There hasn't been a firm decision on when the cutoff date is going to be, but you will, by Kubernetes policy, get at least a year's notice.
Yep, right now we're looking at 1.20 as the release where everything will be pulled from in-tree. So by release 120, which will happen approximately around late 2020, we'll have all the Kubernetes, all the older Kubernetes in-tree provider removed from the Kubernetes core.
So the way this move is structured, it's based on a number of these KEPs, these Kubernetes enhancement proposals. I'm not going to go into the details, but the link, I'll give you a shortened link to this whole deck at the end, and you can go look at those KEPs that have detailed designs as to what's going on with this move out of tree. One thing that is happening in conjunction with the cloud provider is, for exactly the same reasons, there are storage drivers that were built into Kubernetes, and at one time they were monolithic, and those are moving out of tree as well. And if you've got a cloud provider that's integrated with storage, and that's the case with the vSphere cloud provider, where we need an abstraction layer not just to the compute infrastructure and things that go along with it, but also to storage. The storage provider architecture is changing to use something called CSI, the container storage interface. That you can get detailed information on CSI from presentations done by the Kubernetes storage SIG, but the gist of it is that CSI is an orchestrator independent industry standard where you write a driver, and it is capable of supporting not just Kubernetes, but Apache, Mesos, Docker, and Cloud Foundry. And it enabled storage vendors to write one driver that supports more than just Kubernetes. But Kubernetes put in place a storage interface to use these out-of-tree storage implementations. And when you move to the out-of-tree cloud provider, you have to move to the out-of-tree storage plugin as well. They're coupled. That move is coupled together. So I guess with that, I'll move on. So the schedule here is that the CSI, the storage driver for vSphere, is in the first release now. We've declared it alpha, version 0.20, and anticipate a GA in August, a couple months from now. It does have some enhanced features. So one of the things that's happened with both the out-of-tree cloud provider and the out-of-tree storage plugins is that the old versions are no longer having feature enhancements, and new features are going strictly into the out-of-tree. And those new feature adds have been happening since about the beginning of the year. So already we're in a situation where you can do things with the out-of-tree that aren't possible with the in-tree. And what's gone on with the in-tree is bug fix only. So no new feature adds are being admitted into those. So if you want these new features, you might have a motivation to move to the out-of-tree versions right now, even though you're not forced to. What we're going to have going forward is VM independent volume management, what the so-called first-class disk. That is something that came in the later editions of vSphere, where it was possible to define storage volumes that aren't strictly tied to one VM. They have their own existence independently, so that these volumes can be created and handed off from one VM to another. We also have support for straddling Kubernetes clusters across multiple vCenters, multiple data centers, and Fabio is going to give a demo of that later in this presentation. We can also handle both conventional and what are called raw volume mounts. The difference is that a conventional mount attaches in the file system. A raw one appears as strictly a device, and there are certain types of apps, it might be somewhat unusual, but there are applications that are prepared to deal with a raw disk device that doesn't have a file system installed upon it. And then we also have zone support, which is a feature of Kubernetes scheduling that can make the scheduler aware of things like failure domains to have better workload placement behavior. So this interaction with pod scheduling and zones, I think this is where I'm going to hand it off to my colleague.
Yep. And this is going to be right before the demo. So as Steve mentioned, cloud provider and CSI are actually getting new features compared to what we have currently in Tree. So one of these new features is that we're able to schedule pods that have storage that is assigned to a specific zone. So what we have is we can define arbitrarily in vSphere the type of zones that we want to have, so we can specify using tags a data center and the zone where the data center lives, and using those tags we can schedule pods with a specific storage that lives in that specific region or that specific zone. Without further ado, I'm just gonna go on with the demo. I had to record a demo because I wasn't sure if we were able to connect to our system. So it's a recorded demo, has lots of pauses in the middle. Just gonna step ahead and just highlight the major things in the video. So what we have here is we have our environment here is made up with two vCenters. So we have two vCenters, think of them as two independent control planes. The first one we have here as a single data center. It has a cluster, has a bunch of hosts, and it has part of our Kubernetes cluster. So we have a master and we have a bunch of workers here. And this is tagged as region. Let me just get closer. So this is region EU. So it's a European one. And we have a zone that says case region EU all, because we don't have a specific region for this. We just have one. The other vSphere, the other vCenter is connected to two data centers. One data center is in the region US and in the zone US West. So this data center is on the west coast of the US, while the other one is on US East. So it's still in the region US, but it's in a different zone. And here we have the rest of the nodes for our Kubernetes cluster that are spread across the two vCenters. So the first thing we want to do here is we want to deploy our CCM, which is our cloud controlling manager. So the AutoTree cloud provider. And apologies for this, but this is basically a bunch of commands where we're gonna just deploy the manifest that we have here. And this is gonna deploy. These are the manifests that are coming directly from the repo where the CCM lives. If we look at the pods, we're gonna see that we have a cloud controlling manager being deployed. There's only one controlling manager deployed because there's really one that needs to be running, or it has to run on every master node if you have a multi-master cluster. The second step is to deploy the CSI driver. So what we're going to do is we're going to get the manifest for the CSI driver and deploy it on top of our cluster that we have. Maybe it's not visible here, but we're having the same configuration file for both the CCM and CSI. It's called vsphere.conf. Is the same file that is deployed both as a configuration for CCM and for CSI, because we're sharing that configuration file. And what we're doing here, we're basically just creating and applying those YAML files. Now that we applied them, we make sure that they're running correctly. We're going to see a daemon set deployed for CSI, because CSI requires to have a pod running on every single node, because this pod here is responsible for attaching and detaching the disks. So we see that our controller manager is still running. We have a CSI attacher. We have all the nodes. We have the provisioning running. So at this point, we're all good. We have a working environment with CSI. We're able to provision storage. So the next thing we want to do is we want to create a storage class and a persistent volume claim. And I'm going to show that in a second in the demo. And this is highlighting the fact that we have storage cluster, data store clusters. So this is another object in vSphere. So we basically have iSCSI1 cluster, which is a data store cluster that contains data stores that are shared in the specific data center. So there's a bunch of data stores, and we want to target that specific cluster. So we want to target this iSCSI1 cluster on region US, US East. So we're going to open up, and apologies if it's not, there's a little light here, but this is a storage class. It's a type vSphere FCD, which is first class disk. It's going to have a parent type of data store cluster, and the name is iSCSI1 cluster, which is the one that we just saw on vCenter. We're going to mark that with two labels. We're going to say that the failure domain, the zone for the failure domain is Kate's zone US East, and the region is Kate's region US. So we want to have this storage class attached to this specific zone. Now we're going to create it. Just apply the YAML file that we just saw. And now we are ready to deploy our sample application. The sample application is just really just a BusyBox container that sleeps, so the application itself is not doing anything. But the important part is that we are mounting a /data here, which is coming from my FCD volume. And my FCD volume is a persistent volume claim that we're going to see after this. That is a 5 gig virtual disk that is going to get attached to this application. Also, this application will be will have some labels that will deploy and schedule this application, this pod, specifically in this US East zone in the US region. And in a second, we're going to see the persistent volume claim. And this is the one that we just declared up there. This is the persistent volume claim. This is the persistent volume claim. We have vSphere CSI PVC. It's a type read write once, and it's a 5 gig disk. So we apply our test pod YAML. So this is our application. We just go get pod. We're going to see that we have a my CSI application up here. We have my CSI app, which is our application that is being created. Now it is running. So if we describe that application, if we describe the pod, we're going to see that it's mounting the data from my FCD volume, which is our PVC, and it's being scheduled on Kate's worker 9. So if we go back to vCenter now, we see that we're in Kate's zone US East, region US. We have Kate's worker 9. And if we open up Kate's worker 9 and we edit settings to look at the VM itself, we're going to see that we have a secondary disk here attached with a 5 gig virtual disk, which is the one that we just applied through the YAML file. And this is application scheduled on a pretty complex vSphere environment that has regions, that has labels attached to it. And we're able to just define the region and the zone where we wanted that application to be deployed, and the storage will follow the same rules that we have for compute. Let me just go back up here. And this is something that is only available in the Tree cloud provider and CSI driver. If you want to know more about this, if you want to try it yourself, here there's a bunch of references. Obviously, you don't have to write them down. You can look at the slides after we're done here. There's decent documentation for all this. It will get better. We're actually working on a new documentation website with all this, and much better walkthrough and some workflow and some other type of configuration. Right now, there's just a bunch of deployment models that we support, that we document. So if you don't find what's in there, or if you don't find this useful for your setup, feel free to open an issue on GitHub, or just reach out to us on Slack, on the Kubernetes Slack. There's a channel called SIG VMware. There's a channel called, there will be a channel called Provider vSphere. There's going to be open up soon. There's also a bunch of other presentations that we've done in the past. So if you want to learn more about that, if you want to watch other demos, just make sure to check them out. And with that, we are done. Thank you very much. If there are any questions, we're happy to take them.
One thing I'd like to point out, I guess we should have put it in that slide, but it was so crowded there wasn't room. But we did a presentation specifically on the CSI out of tree storage just a month ago in Barcelona, and that got videoed, and the deck is published at the KubeCon Barcelona website, so you can find it there. And that was a whole hour strictly on the storage part, so it's a deeper dive. So you might be interested in that. Any questions?
For CSI, if we want to mount a PVC to a container, we should first mount a disk to the VM, right?
No, this is automatic. This is done directly by.
But if the container migrates to an restarting another node, the disk will mount from the worker and mount to another worker.
Yes. It will be unmounted from the worker and mounted to the other worker.
Do you know what's the for example Ceph or cluster? Is it that necessary to mount the disk to the VM first before container use that?
No, in general, that's a bad idea. It is possible with the Kubernetes architecture, just because they did it a different way at the beginning, to do things like create a volume first and then specifically indicate that you want that exact volume in the pod spec or the container spec. But that's generally deemed to be a bad idea. So there's something called storage classes, where you define classes that you should label with meaningful names, kind of indicating an outcome. If you're familiar with vSphere, it would be along the lines of vvol, where you divide storage into classes of service, like SSD might be fast class of storage, and something that's slow rotating drives might be called a cheap class. And the pods are defined to take advantage of those labels for the classes of service. And that's the kind of thing that makes them portable, where if you had a database that used cheap storage for log files, but fast storage for indexes, if it was based on those labels, you could run it on vSphere, and an admin maps the storage classes to physical data stores or classes, and the users consume based on the outcome specifications. You could take that to a public cloud like Amazon and have a mapping defined to use those same class names, and it just works. It gives you it maps the expensive fast storage for your database indexes and the cheap storage for your log files, and it is portable.
If I take the same example that I shown in the demo with what you were asking, you would see basically we had 3 workers in that specific region. So if you were to drain a node, let's say drain Kate's worker 9, which is the one that the pod was scheduled on. If you drain that node and you remove that node, the pod will be rescheduled, the disk will be moved and reattached to another worker inside that region. So Kate's worker 8, which was in the same region, it will get the disk attached and it will get the pod schedule on.
So under the covers, Kubernetes as an orchestrator along with the CSI is handling these detach and reattach. Now they can't defeat things like if you have data plane communication limitations where certain volumes simply aren't attachable in some zones or regions. They aren't going to create some miracle where it's going to hook those up. But in general, if you intelligently define these, things will just work, and you don't have to manually deal with detach.
As long as you have the underlying infrastructure, the underlying vSphere design done correctly, where you have multiple workers that are able to access the same VMDK, so they have a path to access that VMDK, then it's going to be automatically dealt with by Kubernetes. And CSI, obviously. That's CSI is doing the work, really.
So couple of like operational questions, I guess. So what's involved in, if I've got the current in-tree implementation, in moving? Is it just an upgrade? And
that's a very good question. Right now, like as in today, we don't have a migration path. The migration path is actually pretty convoluted because the in-tree cloud provider, well, the in-tree storage provider, really, it's using a different API in vSphere to deal with disks, while CSI is using the newer API, which is first-class disk. And between the two APIs inside vSphere, there's no clear upgrade path. So we are trying to work around this limitation and try to figure out a path to move people that have like an extensive set of disk and persistent volume created with the old in-tree and move them to the auto tree. But right now we don't have an answer for that, like not today.
Yeah, the storage SIG, now this only applies to the storage aspects and not the cloud provider aspects.
Correct.
But they have a plan to eventually replace the existing in-tree with stubs that would simply call the CSI implementation, but that isn't implemented yet, so you can't get that today. But that's the closest thing to a long-range plan that has been stated, and this isn't unique to the vSphere implementation. The plan is to pull this off for all forms of storage.
the second one was more, you said the admin defines, is it, so if it's vSAN, are they expected to be writing the YAML for the storage class? Oh, it's an operational thing. But
Do you want to take this? Or should I?
Well, for now, yes. There will be changes coming in the vSphere platform that will limit the amount of work you have to do. But right now, this is what you have.
Yeah, and when it comes to admin, there's a concept of both Kubernetes admins as well as admins of the underlying platform. And it depends on your organization how fragmented they are. You know, I've seen some where you have admins for network, admins for storage, admins for compute, and others that's one role where they have 100% visibility. To define these storage classes in Kubernetes, you have to be a Kubernetes admin. Now, you could have another layer where storage admins would provision the underlying infrastructure and simply give enough detail to the Kubernetes admin to enable them to do that, or it could be one person. And that's kind of going to be organizational, dependent on how complex they want to make their own internal organization chart. Anybody else got a question?
Going once? Twice?
Okay, thanks for coming. It looks like this is recorded if you missed anything. And do you want to bring it back up with the link to the deck?
Yeah, absolutely. This should be the right link to this deck. So if you want to open that up, it's a short link. It will get you all the links that we have on this deck. It will also be available on the KubeCon website, so you can just check it out.
And by the way, we have had a SIG going for, I think, over a year at this point, where we have meetings every couple of weeks. There actually was one due this week that we're going to cancel just because Fabio and I will be traveling. But you can join this VMware SIG, and if you're a user, or I think the people who could get value out of that would be people who want to help us develop this. If there are any, that's a rare niche. But if you're a user of Kubernetes running on top of VMware hypervisors, this could be of use to you. So we have users showing up with questions, support requests, feature requests. And the other class of people who could get value out of this is if you work for somebody doing a Kubernetes distribution. Examples might be Red Hat OpenShift. I don't want to plug VMware's own solution because I don't want to be viewed as commercial here, but pretty much everybody with a Kubernetes distro that can run on-prem will support running it on the VMware hypervisor. And if you're working on one of those, you're welcome to come to these meetings, ask questions, or ask for features or discussions. The Kubernetes project is reforming these SIGs that are related to cloud providers. So by the end of the year, the plan is that there will be a user group, and then the group of developers doing the VMware cloud provider are going to be folded into a group underneath the cloud provider SIG. So expect this to change, but for now, those links are good. Join the group and join our meetings. If the time zone is bad because you're in China, the meetings are recorded, both notes and YouTube videos.
And that's pretty much it. Thank you very much for coming.
Yeah. Thank you.